Few days back, I had posted about checking the Wi-Fi signals from an ESP32 development board which I had bought recently. I never imagined that this is a chip capable of sending signals to the QO-100 amateur radio satellite located at 36,000 km in a geostationary orbit. That world record has been created by HB9BLA couple of days back. Normally, the Wi-Fi signals from ESP32 has a range of just below 50 meters. HB9BLA used a software hack which allowed him to make ESP32 work on the CW part of the QO-100 band plan. He used his 1.2 meter dish antenna, which has a gain of 25 dB on the uplink frequency of QO-100. That could amplify the effect of the 100 milliwatt power output from ESP32 to an effective power of 30 watts. That way, he could reach up to QO-100 and hear his CW signals on the downlink. I purchased an ESP32 Dev Kit V1, which is a development board, recently and had posted about it. The board has a built-in Wi-Fi and I thought of checking it out. Connected a power bank to the USB micro B port on ESP32 board using a USB cable so that the power indicator LED was lit up. Then I used my mobile phone to check access to the Wi-Fi signals from ESP32 and I was happy to see it. Connection was obtained easily. It is mentioned that the device is without internet and not secured. Next, I tried to access the Wi-Fi from my laptop. Immediately this warning popped up telling me that Wi-Fi network is insecure. The reason being that network is not password protected. That was from the antivirus software installed in my laptop. Next, I checked the Wi-Fi icon on the taskbar and this was shown, essentially meaning the same. It is an open network and other people might be able to see if you send over this network. There was nothing unusual about these warnings as it is just a development board which had been purchased recently and had not been used for any purpose. Anyway, I was happy that this tiny ESP32 development board has a viable Wi-Fi connectivity built in. I had mentioned about ESP32 microcontroller during the discussion on standalone versions of LMR SDR. ESP32 is a series of low-cost, low-power microcontrollers that integrates both Wi-Fi and Bluetooth capabilities. My new ESP32 microcontroller. You can see the name here, ESP32. This is the reverse side and you can see 15 pins on either side, making it a total of 30 pins. The pins are suitable for mounting on a breadboard. ESP32 Dev Kit V1 is a development board. Silicon Labs CP2102 integrated circuit IC is a USB to UART bridge used to establish communication between a computer and ESP32 microcontroller. UART, Universal Asynchronous Receiver Transmitter, pins of the CP2102 TX and RX are connected to the corresponding RX and TX pins of ESP32. CP2102 facilitates the uploading of code and converts the USB signals from the computer into UART signals that the ESP32 can understand and vice versa. 1117 3.3 is a low dropout LDO linear regulator. It takes a higher input voltage like the 5 volts from a USB input and regulates it down to 3.3 volt needed by ESP32. Power to ESP32 can also be provided to the VIN pin. The yellow surface mount device labeled 106C is a tantalum capacitor for power supply filtering and stabilization.